And we're back. Okay, so look at this circle. Where's the circle? That side. Okay, so there's our circle there. And we need to determine if the reasons the sides of angles marked X, Y, and where is it? Z. Okay, cool. So definitely not going to go through this whole question, but let's look at ideas of how we can get into circles. Let's look at, I don't know, a whole lot of things. We've got X. So one strategy that can be useful is maybe looking at X and going, okay, so how do we create angle X? And I think of it as, let's work backwards. So angle, well, the angle with a value of X, if we go from B and C and we go up to that point. So can you see you're starting at like B and C and you're going up to A. So we've got that angle, and then we can ask ourselves questions like, well, what other angles can we create either at the center or at the circumference of the circle that start at B and C? Well, we can get to angle D. Okay. What do we know about angle D and this angle here? Well, they're equal. And remember, reasons. We need our reasons ready to go as well. So when you get here, you're going to go this equals this. You're going to put a statement and reason for every single statement. That's why it's worth so many marks, even though you're only finding 3 angles. Okay, so if you found D, you could find out X, and vice versa. If you found X, you could find D. Okay, let's check other angles that you could create. Well, from B and C, you could go to O. But this is only useful if O is the center of the circle. Is O the center of the circle? But my question is, why do you know that it's the center of the circle? Because they tell us, right? Here it is. O is the center of the circle. If we are not told it's the center of the circle, we can not just assume it. So please, I don't want, here we've got something and you've got, oh, here we go, there's something, and you start going, oh, well, there we go, that angle's twice this angle in the circumference, but clearly it's not in the center, and if we're not told it's the center, then we can't use that. But in this case, okay, so we've got an angle at the center, and we know some relationship between the angle at the center and the angle at the circumference. Cool, so that's probably going to come in handy. Other things that might be useful. So there we go, that's kind of that strategy. Maybe Z, we've got a similar idea where Z we could say, so let's scrap all of that and say, well, let's look at Z. Remember, I'm showing you ways that you can look at this diagram, and it's going to be you to fill it all in. So if we look at Z, not doing what I said I'd do. Z is from here and we work backwards. So if that's Z created from A and D, can we create other angles? Well, again, from A and D, you could create this angle across here. So that angle is equal to Z. And there's another one. Well, we could create this angle at the center. Hey, do we know anything about the angle at the center compared to the angle at the circumference? Well, if we knew this angle, then it would be mighty handy, because then we knew what Z is. Now, you're going to need something else. That looks like something we've done before as well, so you can work out that. That might be on. Remember, there are going to be lots of ways of figuring this out. You might have said, well, once you figured out X, you figured out this angle. This is angles on a straight line, so this is 40. So Z, you worked out angles on a triangle. Hey, there's a cool way of doing it. So don't get stuck into looking at the memo. And I know I bang on about this too often, perhaps, but really, that memo is going to show you one way, and really spend time grappling with these diagrams. Figure out everything. You might fill in a whole lot of things and go, that's 40, oh, then angles around a point, therefore that's going to be whatever it equals 140, and you didn't see the vert opposite angles are equal. That's fine, as long as for every statement you've got a reason. I was going to say, is this a useful thing or not? I struggled with this at school. I was much stronger at algebra, and my diagrams were full. And I actually did quite well at this, but I took the long way around to get there. So I really would have gone 40, 140, 40 angles in a triangle. I wish that they asked me to figure out every single other angle, because by the time I was done, I'd figured them all out. Meant that I'd work quite quickly because my 7 marks in 7 minutes got eaten up quickly. Anyway, not too concerned with that, I'm sure. So let's have a look. So angle Y, let's do the same idea. So angle Y, let's go backwards here. Of course, I already mentioned angles in a triangle and things like that, so don't just use this strategy, but it seems to work so often. So here's angle Y. Can we create any other angles on the circle at the circumference or the center from B and C? So go for it. Well, we could create this angle here at the center. Do we know anything about the angle at the center compared to the angle at the circumference? Yeah, just be careful. It's this whole angle is twice that angle if you're going to use that. Or maybe we're going to do something else, and that is what happens if we've got, let's see, we could also go across to this side. And you'll see that what this has just created. Hey, look, there's one side, there's another side, there's another side, there's another side. What do we call a quadrilateral in a circle? Well, more correctly, what do we call a quadrilateral where all the vertices on the circumference of the circle? A cyclic quadrilateral. So therefore we know something, there's a relationship between angle Y and angle X. But hey, look at that, you could have started with Y. Generally it makes sense to go in order, X, Y, Z. But if you had started with Y, because you're going, oh well, if that's 140, that's 140, that's 40, that's 40, angle at center, twice angle at circumference, and then from there gone into X. Cool, that works well. If you had worked out that whatever X is, let's say that X turns out to be 70, so let's say you went 70, so you went, cool, that's 70, that's 70. Hey look, exterior angle of a triangle. There are just so many ways. Can you see it? And this is useful time to spend, is deconstructing diagrams in multiple ways, because it's just going to build your strength in doing others. So suddenly you go, hey, look what I've just spotted. I see a triangle. I see an exterior angle. What do we know about the exterior angle compared to the opposite interior angles? Well, it's the sum of them. So Z equals 70. What about this? I mean, there's even something else here. I'm really seeing these as I go. There's a reason that I come in fresh and don't just go, oh, here we go, X is this. I remember talking about this at some stage. There's a center. What's so special about these lines here? OD and OC. They're radii. And what do you know about radii? Hey, they're equal. So if we made a triangle, let's complete our triangle. What type of special triangle is that? Isosceles triangle. So therefore, that angle is going to be equal to that angle. So if you found your 70 and went 70 and then went isosceles triangle radii, great stuff. Every statement must have a reason. Look how many ways. Isn't it wonderful? Okay. But it is quite cool that there's so many ways that you could deconstruct this. And it's good practice. As I said, go through it. Find out different ways of finding out the same angle. Solve the rest of the triangle. Hey, are there any other isosceles triangles? Well, there's one there. So if that equals that, then you can work out that angle. Oh, wait a second. If I've got X, this would be a good exercise actually, is determine all the angles in this if you can. What do we know about the angle in a semicircle? Oh, well, that's 90 degrees. So if that was 70, that's going to be 20, that'll be 20, 70, 70, 40. Does it all work out? Yeah, there's some more cyclic quadrilaterals here. Look, there's one over there. Doesn't matter that it goes through the center, still a cyclic quad. So there's that angle and that angle are the same. So yeah, you get the point. But really, go through it. Push yourself on these ones, because it's going to help when they get, this is a more proofy one, I think. But yeah, when you get to the more complicated ones, I think these ones, here we go, these types of things, then it's useful to have really pushed yourself in the others. Okay, that's that for now. Let's finish off where we started, which was over there. Every statement, reason, go for it in a whole numerous myriad of ways.